Okay, so for some inexplicable reason, my Wi-Fi keeps going down. So I'm going to have to stitch these two videos together. But I apologize very much for the hassle. We'll pick up where we left off. So, um, we said that we need 3 hybrid orbitals and 1 regular p orbital. And the reason we need that is we remind ourselves of our rules. Sigma bonds go in hybrid orbitals, unshared electrons go in hybrid orbitals, but pi bonds do not go in hybrid orbitals, which means that we have here, what colors did I use again? I used yellow for unshared pairs. These are the unshared pairs, or the unshared pair, singular of electrons. And then that's going to make a sigma bond, as is that. But this guy here is ready to make a pi bond. Now, you may be asking yourself, why in the name of all that is good and holy do we even care about this? Why does it matter? Just trust me, we're a day away from seeing why it matters. It has everything to do with shape. And the thing you're going to learn in chemistry this year is that shape is really, really, really important. Shape is how we know this happens, or the reason we've, come up with this explanation for what happens. But shape is also really important for understanding how molecules work. And you've never really had to think about that before. We always just said things bash into each other and then they react. And that's true, but the truth is that things bash into each other and they react, and their shape has a lot to do with how they react. So, hybrid orbitals and regular orbitals and knowing the difference. I'm going to remind you of this 6,000 times, so it'll stick in your brain that unshared electrons go in hybrid orbitals, sigma bonds have to happen in hybrid orbitals, but pi bonds have to happen in non-hybrid orbitals, either a regular old p orbital or a regular old d orbital. All right. We're going to look at one more example today, and I'm not going to give you any homework today or anything like that. We're just going to let this vegetate in our brains because this stuff's tricky. And then we will consolidate. We'll put it all together. So, let's take a look. Last example, what if there are 2 pi orbitals? Which, by the way, you should already know the answer what happens if there's 2 pi orbitals, because you know what pi orbitals need. But let's take a look at carbon dioxide. And carbon dioxide, you can draw the Lewis structure of. Pause this video, give it a try. All right. I'm assuming you've unpaused it now. Let's take a count. We know that carbon is going to give us 4 electrons, and we know that 2 oxygens is going to give us 12 electrons. There's no charge, so this totals 16 electrons. All right, we have 16 electrons to work with. We put the least electronegative atom in the center, that's carbon. We put the others around it, and we draw a single bond between them. Now we go and add our electrons, and we complete the octets. So 1, 2, 3, 4, 5, 6, 3 more pairs there, and 3 more pairs here brings us to 8 and 8. That brings us to 16 electrons, right? 2, 4, 6, 8, 10, 12, 14, 16, 18. 2, 4, 6, 8, 10, 12, 14, 16. 16 electrons. But, obviously, carbon is missing 2 pairs, and the only way that can be accomplished is by sharing. So we're going to share these ones here, and that means that this is going to have to be a second bond, and that's going to have to be a second bond. And if you remember, we always said that the second bond is a pi bond. So there's a pi bond, and there is a pi bond. On the other hand, those first bonds, we said those are always sigma bonds. There we go. I don't really know why I wrote that twice. I suppose it would be just as good to go like that. And really, I could do the same up here. All right, there we go. So we've got 2 sigma bonds and 2 pi bonds. So let's talk about carbon. If we look at carbon here, we can say, okay, well, carbon normally has 1s with 2 electrons. It has 2s with 2 electrons, and then 2p. Well, carbon has 4 electrons total in its outer shell, so it would look like that and like that. We've already drawn carbon, so I didn't feel the need to rush to it too much. But remember, we need two hybrid orbitals for sigma bonds, and we need 2 non-hybrid orbitals for pi bonds. So what's that going to look like? Well, for the hybrids, we're just going to say, okay, we'll hybridize that and that. Those will be our hybrids. And for the non-hybrids, we will leave these alone. And in that way, we can look over here and say, after the hybridization, carbon will still have a 1s. That will still be full. But now, we have that hybrid orbital, right? The hybrid orbital here. And what's that? Well, it's in the second shell, so we'll call it 2. It's made from an s orbital and a p orbital, but just an s and a p. There aren't 2 p's, there aren't 3 p's. It's an s orbital and a p orbital. So we just call it an sp hybrid, not sp2, not sp3, just sp. Just sp, because it's only 1s and 1p orbital. And we still have the 2p orbitals unchanged. And let's remind ourselves what's happening. Well, we have 4 electrons. 2 of them will live here. Those are going to make sigma bonds. And 2 of them will live there. Those are going to make pi bonds. So these will make sigma bonds. And these will make, wow, that's the worst brace bracket anyone's ever drawn. Make pi bonds. All right, and there we are. Oh boy. Oh boy. It's a complicated topic. All right, don't be intimidated by it. Don't be stressed out by it. You are more than smart enough to figure this out. I promise. I would tell you if you weren't, and you all are very capable of doing this, but it's complicated. All that means is we're going to take our time and go slowly with it. All right? By the end of this unit, you'll be shouting out SP hybridization, SP2, SP3 hybridization, all this crap like crazy. Tomorrow, all we are going to do is some practice with this. There's some homework written down on this page. You can make an attempt at it. That's fine. That's fine. But tomorrow, we're going to go through this and a bit more practice and just work on this. Make sure it makes sense to us. All right? I will do my best to take a look at Teams today. If you have any questions, shoot me a message. I don't promise I'll see it, but I'll do my best. I'm actually going to be at the school after school for volleyball, so you could swing by if you really had a pressing question and find me. Otherwise, you're doing great. This is heady stuff. It takes some time to sink in, so we're just going to let it sink in. All right? We're not going to try and rush it. All right, ciao. Take it easy, guys.